can't always solve any nonlinear system by elimination, because when we use the elimination method, we can only combine like terms. In this example, the second equation doesn't have an x squared term, and it doesn't have a y squared term. So if we were to try to solve this by elimination, we wouldn't be able to get rid of the x squared term, we wouldn't be able to get rid of the y squared term, therefore we would end up with an equation that had both x and y still in it. So elimination won't work here because the terms don't line up properly. We have to solve this by substitution. And this is not set up to make substitution as easy as possible, because neither one of the equations is solved for x or for y. Looking at these, it's definitely going to be much easier to solve equation 2 for one of the variables. So that's what I'm going to do. I'm going to solve 2 for y. To do that, I'll just divide both sides by x, and we'll get y is 2 over x. And then we'll plug that into 1, and we'll have x squared plus x times 2 over x plus 2 over x squared is 7. Let's see, multiplying this out, x squared plus x times 2 over x is, well, it's 2 as long as x is not 0, right? We can only do this if x is not 0. Plus 2 over x all squared is going to be 4. That's 2 squared over x squared. And now this is a rational equation. We need to get rid of that x squared in the denominator to solve this. And to do that, we'll multiply both sides by x squared. Now keep in mind, we're multiplying both sides by a variable, but we already ruled out x being 0. So this is fine. And distributing, we've got x to the 4th plus 2x squared plus 4 is 7x squared. This is a polynomial equation, so we need to get all the variables on the left. X to the 4th minus 5x squared plus 4 equals 0. We can pretend that that's quadratic, and we'll get x squared minus 4 times x squared minus 1 equals 0, which means that either x squared equals 4, so x is plus or minus 2, or x squared equals 1, so x is plus or minus 1. Okay. Well, we've got 4 different values of x. Let's find the values of y that go with them. If x is 2, y is 2 over 2, which is 1. If x is negative 2, then y is 2 over negative 2, which is negative 1. If x is 1, y is 2 over 1, which is 2. And if x is negative 1, then y is 2 over negative 1, which is negative 2. And again, when we check all of those in equation 1, we see that all of them work. So we actually have 2, 1, negative 2, negative 1, 1, 2, and negative 1, negative 2. This system has 4 solutions. Okay, so that was a system that we had to solve by substitution because we didn't have enough terms to eliminate all of the variables. In this example, however, we notice that both equations have an x squared term, both equations have a y squared term. We can use elimination to eliminate either one of those. Because all of the terms line up, using elimination will work for us here. Let's see, I think I'm going to take -3 times equation 1 plus equation 2. I'm going to eliminate my x squared. So -3x squared minus 3y squared is -15. 3x squared plus 5y squared is 23. Adding those together, because we're using elimination, we get 2y squared is 8. So y squared is 4. So y is plus or minus 2. Okay, so we have two different values for y. Let's see how many solutions we get this time. If y is 2, I'm going to plug into 1 because that makes my life easier. X squared plus 2 squared is 5. X squared plus 4 is 5. X squared is 1. So x is plus or minus 1. So I got two different x values that go with this first y value. That's actually going to give me two solutions. -1, 2, and +1, 2. So I plugged in the single y value and I got two different x values to go with it. If I plug in y equals -2, then I've got x squared plus -2 squared is 5. X squared plus 4 is 5. It turns out this is giving me the same thing. So I also have x is +1, y is -2, and x is -1, y is -2. So that y equals -2 gave me the same two x values. It could have given me two different x values. It could be that one gives me one x value, the other one gives me 2. All sorts of things can happen. In this case, I got 4 separate solutions out of 2 different y values. If we plug them into the second equation and check, we'll see that all of those actually work as well. In fact, it's really easy to see that that's going to happen, because if we square our x and we square our y, we'll get the same result for each of our solutions here. Okay, so when we meet a system of equations in the wild, then, how do we settle on a method, and what else can go wrong? That's what we'll see in the next video.